Assalamualaikum warahmatullahi wabarakatuh. We are from group 1 and we are going to present about single phase induction motor. What is single phase induction motor? Like its name, it is a motor. It is a squirrel cage rotor with scattered or concentrated stator winds specifically designed to supply a power in a single phase. The AC voltage applied on the single phase status winding generates an alternating magnetic field phi that is stationary in space, that can be broken down in two fields, which is phi1 and phi2, which rotate in opposite direction, thus makes the resulting phi can be broken to phi1 plus phi2, as you can see in the diagram, like that. The magnetic fields phi1 and phi2 create electromotive forces within the rotor's windings, through which electric currents flow through the rotor's windings. Therefore, the rotor cage also produces two magnetic fields which rotates at opposite angles. So the interaction between magnetic fields from rotor and stator will result in a resultant magnetic field as you can see in the diagram. The combination of these moments provides an electromagnetic torque that is characteristic that is produced by an uniphase induction motor. Based on the properties of the magnetic torque, it's evident that a single phase induction motor doesn't generate an initial torque at n equal to 0. It is unable to start its operation by itself and does not have any particular direction of rotation. It is, however, enough to provide the rotor of a single phase motor and starting speed in any direction until the point at which the magnetic torque exceeds the load torque from the outside, which means that the motor can begin to spin and reach a subsynchronous speed within the stable portion of the force characteristic of M. So we can conclude that the single phase induction motor is regarded as two motors working on a common shaft where the flux spin in opposite direction. To attain a beginning torque, most single phase motor models are fitted with additional starting windings that are connected to capacitors. So enough for the theory. We move to the application. So this motor is connected to low power AC supply, which basically means it produces low power. So it is used in low power appliances such as household appliances like washing machines, refrigerators, low power technology equipment such as in agriculture industry, and auxiliary drives in industry. So the single phase induction motors consist of two main parts, which is stator and rotor, and one auxiliary part, which is windings. What is stator? Stator is a stationary part of the motor and contains a series of windings that are evenly spaced around the inside circumference of the stator. What is rotor? Rotor is the rotating part of the motor and is placed inside the stator. It consists of a series of conductors arranged in a specific pattern. And windings. Windings are connected to a single phase AC power source and produce a magnetic field that rotates around the stator. The difference between stator and rotor is that stator are attached to windings, but rotor doesn't.
Assalamualaikum. I'm going to talk to you about the operating principle of a single phase induction motor. The operating principle starts with a single phase AC is supplied to the stator winding, and then it will produce an alternating current flowing through the stator winding, which then produces an alternating flux around the rotor, which we can call this as main flux. And then according to Faraday's law, the actual electromagnetic force will be induced in the rotor, and then a current will start flowing in the rotor, and that current flowing in the rotor will produce another flux, which is called rotor flux. And then the main flux and the rotor flux produce a desired torque, which helps to make the torque to produce a torque for the motor to rotate. According to double field revolving theory, any alternating quantity has to be divided into two components which have opposite direction, and it has half of the maximum magnitude of the alternating quantity. So since the two components, in this case the alternative flux are exactly opposite to each other and they have the same magnitude, these two components will cancel each other, and then the net torque experienced by the rotor at the starting condition will be equals to 0. And from these operating principles, it concludes that a single phase induction motor is not self-starting motors. So to counter this problem, my friend will explain how to adjust the single phase induction motors to be self-starting motors.
Now, moving to the last part, we're gonna talk about the types of single-phase induction motors. Basically, there are 5 types of single-phase induction motors. The first one is a resistance start motor, second is capacitor start motor, third is capacitor start, capacitor run motor, and fourth is the permanent capacitor motor, and the fifth one is a shaded pole motor. Now, let's see the first method, which is the resistance start single-phase induction method. In this method, we connect a high resistance in series with the auxiliary winding of the motor as shown in the figure. The overall inductance in both of the windings, we can see that the auxiliary winding has a high resistance but a low inductive reactance. Meanwhile, the primary winding has a low resistance but a high inductive reactance. Due to this, the primary winding current IM lags the applied voltage by 65 to 75 degrees, while the auxiliary winding current IS lags by 35 to 45 degrees. Thus, there is a difference of about 20 to 30 degrees between both currents as shown in the phasor diagram. Although there lies a small phase difference between the currents, it is still sufficient to start the motor. As the motor reaches 75 to 80% of synchronous speed, the centrifugal switch disconnects the auxiliary winding from the motor circuit. It protects the auxiliary winding from overheating and burning. There are some applications of this single-phase induction motor, which these motors are ideal only for small initial loads that require moderate starting torque. And it also includes woodworking tools, grinders, fans, and blowers. Now let's move the second type of single-phase induction motor, which is the capacitor start single-phase induction motor. It is an improved form of the resistance start method. It contains an electrolytic capacitor in series with the auxiliary winding. In this case, the auxiliary winding has a higher capacitive reactance. Meanwhile, the primary winding has a high inductive reactance. Due to this, the current in the primary winding lags the applied voltage, while the auxiliary winding current leads the applied voltage as shown in the phasor diagram. It is visible that the phase difference between the currents has increased significantly, hence the starting torque of the motor also increased. There are some applications of this type of motor, which the capacitor start motors are efficient to use in fans, blowers, jet pumps, and sump pumps. Also, they are ideal for farm and home workshop tools and oil burners. Let's move to the third type of single-phase induction motor, which is the capacitor start capacitor run single-phase induction motor. Although the use of an electrolytic capacitor increases the starting torque, it has two problems. The first problem is that these capacitors are rated only for short-duty service. It gets damaged if used for a longer time. And the second problem is that the dielectric of the capacitor gets damaged if the motor is started too frequently in a short time interval. So, to get smooth starting and running conditions, we use capacitor start capacitor run motors. It uses two different capacitors placed parallel to each other. This method is different from the above two types of single-phase induction motors. Here, the auxiliary winding remains connected in the circuit at all times, both starting and running. Now move on to the fourth types of single-phase induction motor, which is the permanent capacitor induction motor. This motor uses only one capacitor in series with the auxiliary winding. Here, the capacitor remains connected in the circuit during the starting as well as running, so there is no need for a centrifugal switch. The advantages of this motor are similar to that of a capacitor start, capacitor run induction motor, but due to the use of only one capacitor, this motor can't give optimum starting and running conditions. It uses a parallel insulated foil capacitor. There are some types of applications for this type of induction motor, which they are ideal for ceiling fans, blowers, room coolers, and other domestic applications. Due to the simple reversal of the motor, they are best for induction regulators and furnace controls. Now, let's talk about the last type of single-phase induction motor, which is the shaded pole motor. This motor is entirely different from the previous induction motors. It does not have any capacitors or moving switch parts. Its stator has salient poles provided with its exciting coil. A copper strap shading coil wraps around 25% of the stator pole, as shown in the figure. Now let's talk about the working process of the shaded pole motor. A single phase supply to the stator coil sets an alternating magnetic field in the core. This alternating magnetic field interacts with the shading coil and induces a current in the shading coil. The shading coil current creates a flux, shading coil flux, which lags the main coil flux by some angle. It appears that the field flux shifts from the unshaded portion to the shaded part of the pole. This shifting of flux is like a weak rotating field. This rotating field interacts with the rotor and creates a starting torque. There are some applications for this type of induction motor. Due to low starting torque, they are only suitable for toys, small fans, electric clocks, and they are also ideal for small businesses machines like photocopying and vending machines. Okay, that's all from us. Thank you for listening and may you have a nice day ahead. Bye!